No surrender to the landscape. There was only one option: drill through rock hundreds of millions of years old. This train is no longer just running, it is flying. Deep inside Japan, there is a colossal mega project that has been built in near silence. For more than half a century, a machine shaped like a steel arrow, racing at 603 kilometers per hour, so fast that it makes every familiar idea of a train feel outdated. This is not just a means of transportation, it is a declaration that humanity has not stopped challenging its own limits. But the most shocking part is not the speed. It is where this machine is going. 86% of this line runs straight through mountains, no detours. No surrender to the landscape. There was only one option: drill through rock hundreds of millions of years old. Through geological fault lines, through underground rivers, through pressure powerful enough to crush steel.
This is no longer just a transportation project. It is a direct war between modern engineering
And some of the harshest terrain in Japan. And it all began with what seemed like an impossible dream. After creating the Shinkansen in 1964 and changing the world, Japan did not stop at asking, "What have we achieved?" They asked the next question: what comes after this? As the Tokaido Shinkansen
became increasingly overloaded, Japan realized the future would not come from improving speed by just a few more percent.
The future would require an entirely new path, a straight line through the heart of the mountains.
A train that no longer needed to cling to the rails the way humanity had done for centuries. And then the true cost of that dream began to reveal itself. From an initial estimate of $9 billion, the project has swelled to $72 billion. And it is still rising. Hundreds of kilometers of tunnels have been consumed by hard rock. Schedules have been torn apart by unpredictable geology. And tunnel-boring machines weighing thousands of tons have been chewed up by the mountain as if they were toys. In some sections, cutting discs survived only a few dozen meters before needing replacement under some of the most dangerous underground conditions imaginable. In others, ancient shale collapsed without warning. Elsewhere, groundwater poured in with such force that engineers had to pump out tens of thousands of liters every minute just to keep the tunnel from turning into a concrete grave beneath the earth. And yet Japan did not stop. Because what they are building is not just a faster train. They are building the next version of ground transportation. The secret that allows the maglev to fly is not found in a conventional engine,
nor in flashy technology displayed on the outside. It lies deep within.
at temperatures colder than the empty space itself. Superconducting magnets are kept at around 4 Kelvin. Point near absolute zero using liquid helium. At that temperature, physics changes. Friction is removed from the game. And at that exact threshold, the train begins to lift itself off the guideway. Suspended on an invisible force that took humanity decades to learn how to control. The train is no longer running. It glides like a guided bullet driven by magnetic force.
Inside, passengers experience only a cabin that feels quiet, clean, almost ordinary.
But hidden behind that ordinary appearance is a machine controlled down to the millimeter,
where every coil, every section of guideway wall, every variable frequency power system is working together like an orchestra that cannot afford a single mistake. That is why this project is both astonishing and frightening. Because in order to cut the trip, a gamble against geology, against time, against politics, against environmental opposition, against money, and even against its own technological reputation.
At one point, the entire mega project was nearly stopped by a section only 8.9 kilometers long in Shizuoka.
Just a tiny slice on the map, yet enough to freeze a system worth tens of billions of dollars for years. Concerns over water supplies for hundreds of thousands of residents turned the project into a conflict.
That was no longer purely about engineering. It became a much larger question. How far is humanity willing to go to touch the future?
Hold it steady! Don't let it buckle! It's too heavy! We're losing it! Watch out, incoming!
It is a race against the world. Japan does not simply want to operate a new rail line.
It wants to be the first nation to prove that ultra-high-speed magnetic levitation can become the true backbone of future transportation.
A future where airplanes are no longer the only answer for high-speed intercity travel.
A future where mountains are no longer barriers, but objects to be pierced. A future where precision, discipline, and ambition are forged into steel, concrete, and magnetic force. From a laboratory in 1962, to the first test tracks, to hundreds of kilometers of tunnels through mountains, to the 603 kilometers an hour world record, and toward commercial operation in 2034. This is no longer the story of a train. It is the story of how a nation spent more than half-century turning the impossible into something that could carry people every single day. A flying train. Through mountains. At a speed that forces the world to rethink the meaning of fast. And if they succeed, then what is racing through that darkness is not just the maglev.
It is the future of Japan, and perhaps the future of the entire world.
This is no longer the story of a train.
It is the story of how a nation spent more than half a century turning the impossible into something that could carry people every single day. A flying train. Through mountains. At a speed that forces the world to rethink the meaning of fast. And if they succeed, then what is racing through that darkness?
Point is not just the maglev.
It is the future of Japan.
And perhaps the future of the entire world.